Hi everyone, this is Mrs. Jackson bringing you a video on how to solve radical equations. Specifically, we're going to look at how to solve an equation that has a square root in it. Like solving all other equations, our job is to use inverse operations and properties of equality to peel everything away from that unknown, that variable x. We're going to try to isolate that variable until it stands alone. Okay, so when we smush everything together, a bunch of operators, numbers, variables, we use the order of operations. Some of you may refer to that as PEMDAS. Well, when we're peeling everything away, such as solving an equation, we're going to use the order of operations in reverse order. So let's take a look at those order of operations. Okay, so if you Google order of operations, and that's what I did here, you'll end up with a number of different graphics that look just like this. So you'll typically have the letters PEMDAS spelled out. Multiplication and division are put on the same level because you perform those left to right, as well as addition and subtraction, same level left to right. And you'll see this P up here listed as parentheses. And that's one of the big hang-ups I have with PEMDAS, if you will, because really that top line should be a G. It shouldn't be parentheses, it should be all forms of grouping. There's many different types of groups, and in fact we have a group in this equation here, so that's why I want to point that out. The other thing I want to point out is that E for exponents, when we're dealing with radicals, radicals are considered an exponent. For instance, a square root is the same thing as an exponent of 1/2. So that's the other thing I want to point out here, is that exponents and radicals are at the same level. Alright, great. So now let's take a look at our problem here. So always, when we try to solve an equation, we go to the unknown, we go directly to the unknown, we look what's around it, we undo those operations using properties of equality. So let's take a look at what we have in our example here. The first thing we see is this expression x minus 3 is underneath this radical. So we certainly do have an exponent slash radical level here. But the expression x minus 3 is also a group. It's kind of stuck together inside that radical. So you could consider this a group. And if there were more things in there, okay, if we could do some simplification in that group, we would do so. We would try to simplify anything we could in there if possible. Of course, x and 3 are not like terms, so we can't do anything in there. But I do want to mention that you would want to simplify anything there. You could. All right, the next thing we see is our radical is being multiplied by 5, so that would be multiplication. And finally, we are adding 4, so that would be the bottom of the ladder. So you could see in this case, this one little problem, we have a lot going on. And we're going to take a look at each one of these from the bottom up. All right, so the first thing we encounter on that bottom of the ladder is addition. We undo addition. The inverse operation of addition is subtraction. Subtraction property of equality. We would subtract 4 from both sides of the equal sign. So we end up with 5 square root of x minus 3. Taking 4 away from itself, of course, would reduce to 0, and 14 minus 4 would be 10. The next thing we see in the ladder is multiplication. We undo multiplication with division, inverse operation. So the division property of equality, I'm going to divide both sides of the equal sign by 5. And of course 5 divided by itself reduces to 1. So I have square root of x minus 3 on the left, and 10 divided by 5 is 2. So I've taken care of both of these bottom levels here. And next we are encountering our group inside that radical, and we're going to undo that radical. Now the inverse operation of square root, and of course remember there's always this invisible 2 here for the square root. The inverse operation of square root is squaring. So I'm going to square the left, and when I square the left side of the equal sign, I've also got to square the right side of the equal sign to maintain equality. And a squaring of a square root, they are yin and yang, they undo each other. So I break out that x minus 3 over here on the left, and 2 squared is 4. And we've taken care of that level. And now we've got our group kind of broken out, and we're going to go all the way back down. We actually have a subtraction of x here, and now we're going to undo that subtraction with addition. So in this case, x equals 7. And you can go ahead and substitute x equals 7 back into the original equation. Of course, 7 minus 3 is 4. The square root of 4 is 2. 2 times 5 is 10. And 10 plus 4 is 14. So everything checks out. I hope this helps. Thanks for listening.